will be sent to you again, okay, so that whenever you find something is missing, you can watch it. So today I'm going to present you a presentation, and what's that? Let me see here if I have got. Okay. Yeah, it came here. Okay. Okay. So what is the objective of today's lecture? Okay, why we need to be here? Okay, and then why we need to listen to today's lecture? It's a very important lecture. Why? Because we'll have an overview of the syllabus on. Okay, so whatever or the every moment of our class duration here, we focused on the overview of the syllabus. So we won't be going to the syllabus. So we won't be reading any chapters, but we'll be overviewing all the syllabus that is there on modern physics, because I'll be teaching you modern physics. So what are different chapters that are here in modern physics, okay, and how we need to study that, and why we need to study the chapters on this modern physics. Today we'll have an overview on that one, okay. And then so what do we mean by modern physics? Okay, so here is the word modern. So what actually we mean by modern, right? Up to now we have been saying physics. Now from onwards we'll be studying about modern physics and classical physics, okay. Whatever stuff we have studied in grade 11 was related to classical physics. Now we'll be studying about modern physics. So what do we mean by modern physics? It deals with the study of atoms. So modern physics is a physics that deals with the study of atoms. So you may ask me the question, right, sir, we have already studied in grade 11. So if I ask you the question, how did you study in grade 11? You will be telling that, so we study about atoms in chemistry. So is the modern physics just like a chemistry? So for this one, I'd like to say, yeah, it largely overlap with chemistry, okay? Whatever topics that you'll be studying in modern physics, they also come in chemistry. So modern physics highly correlated with chemistry. Now, so what is the methodology of today's lecture? Okay, then if we have to have an overview on the modern physics, and if you say that is largely overlap with chemistry, then what are different steps that you'll be taking today in order to study the lecture, okay? Or in order to understand the syllabus of modern physics, what are different steps that we're taking. So the first step is, as I mentioned, you will have the brief overview of all the chapters. Whatever the chapters are included in modern physics, we will be going through it. We'll understand what are different chapters and what are the key points that we have from that chapters. And then after that, second step will be going for the question format. Okay, how many marks question is coming from modern physics, and what are different chapters from which these questions are coming. So we'll be going to that format, question format. And then I have written your quizzes, but I do not want to go at the end. I want to ask you, and I want to make you interactive in between. So I'll be asking you quiz questions in between. Okay, so just after finishing certain slide, there will be a slide check your understanding. Then at that time I'll be asking you, and for that one I'll ask you individually. Okay, so if I do not get your answer, then that's a real problem. So please listen attentively. And if you have any question while I'm delivering the lecture, where we are understanding what we are going to study in today's lecture, then you can ask me questions, okay? Either in the chat box, or you can unmute yourself, just like Chetana and Prapti and then Swapnil did. In that way, you can ask me the questions. So, as a first step, we'll be overviewing all the chapters, okay? And then I have categorized our chapters into three categories. The first category is this one. So if you see here, what is this? Tell me, what is this? So one of you just unmute yourself and then tell me what is this?
Electron.
Yeah, very good, electron. Okay, so this is an electron. So in today's lecture, not in today's lecture, in modern physics, the first chapter that we'll be covering is electron, and it's really interesting chapter. Look, you'll be discovering electron. I'm telling you, okay, you'll be discovering electron. So you'll have the mindset of that scientist who discovered electron. Okay, so what you'll be doing, first of all, how will you approach this chapter? First of all, we will discover electron with the mindset of J.J. Thomson. Then after discovering this electron, we'll put it into electric field. Yes. After discovering electron, we'll put this electron into electric field, and then we'll try to find out what happens. Okay, how does the electron behave in electric field? Not only we'll put in electric field, we'll also put this in magnetic field. Okay, so right after the discovery of electron, we'll have that mindset of J.J. Thomson. We discover this electron. Then right after discovering electron, right after knowing how we can discover electron, then we'll put that electron in electric field, and then we'll see the behavior of that electron. Okay, how does it behave? Then we'll put into magnetic field. Okay, so electric field and magnetic field we'll put separately. And then finally what we do is that we'll put that electron in both electric and magnetic field simultaneously. Okay, so there will be certain platform where there will be electric field and there will be magnetic field placed simultaneously. Okay, and then we'll place that electron in that. And how does it behave? We'll be just finding out that one. And through that experiment, we'll be trying to find out the specific charge ratio of electron. That is, we'll discover what's the value of E by M. So first and foremost, we'll have the mindset of J.J. Thomson, and we'll discover electron. Then we'll place that electron in electric field. Then we'll place that electron in magnetic field. Then again, we'll question ourselves, what happens if we place this electron in both electric and magnetic field placed simultaneously? Okay, that means electric field is also present over there. Magnetic field is also present here, over there. Then we'll just put the electron on that one, and we will find out the specific charge ratio E by M. Okay, so not only that one, in grade 11 we have studied that charge is quantized, right? Any one of you tell me what is the quantization of charge? What is the quantization of charge? Anyone? You please unmute yourself and then you please tell me. Hello? Hello, no one is speaking. Speak, please. Are you listening to me or not? So let me ask. Okay, Sasank, you unmute yourself and then tell me what is the quantization of energy? Sasank.
Charge of a single electron.
Charge of a
single
electron is it? Is it charge of a single electron? Okay. Now let me ask Rasi, tell me what is the quantization of energy? Rasi? Hello, Rasi?
Yes, sir.
Okay, you please tell me what is the quantization of energy? Quantization of charge, sorry. What is the quantization of charge?
Sir, the charge in a single electron.
The charge in a single electron is known as quantization of charge, is it? Was
So
that
maybe.
what we studied? Was that what we studied in grade 11?
Sir, I'm not sure.
Okay, fine. Nice interaction. Okay. So it doesn't matter if you are wrong here. What it matters is that if you do not take part. Okay. Now let me ask to Serena. Serena, you unmute yourself and then do please tell me what is the quantization of charge? Or you just tell me the formula. No need to define it. Just tell me the formula expression for quantization of charge.
So charge of a single electron.
Is known as quantization of charge. Okay. Okay, and then whoever finishes talking, you mute yourself. Okay. Now Prithvi, unmute yourself and then tell me what is the quantization of charge.
Sir.
Yes.
Charge of single atom, sir.
Oh,
single
charge of a.
So formula one now, sir.
Oh, formula one. You can tell me the formula. Okay. Tell me, what's the formula? Okay, do not see book and etc. If you don't know, just tell me you don't know. Okay, now let me ask you, Prapti. Prapti, unmute yourself and then tell me the formula for quantization of charge.
So Q equals to N.
Yeah, Q equals to NE. Exactly. Q equals to NE. Okay, thank you, Prapti. Okay, now, Prapti, do not mute yourself. Okay, Prapti, unmute yourself and tell me what you are seeing on the screen. Are you seeing this one? Brief overview of all the chapters.
Yes, sir.
Okay, okay,
Electron.
thank you. Okay, thank you. So in grade 11, we study Q equals to NE, okay? Charge is quantized, okay? And then just like in grade 12, you'll be studying the experiment regarding that one. How can we say that charge is quantized, okay? So that one we're studying in grade 11. So in this first chapter, the key takeaway point is we'll have the mindset of J.J. Thomson, and we'll discover the electron. Then we'll place that electron in electric field, and we'll place the electron in magnetic field, and we'll place that electron in both electric and magnetic field. Then we'll find out E by M, specific charge ratio, the value of E by M. And not only that one, we will prove what we studied in grade 11. In grade 11, we studied that charge is quantized. I shall come on to that while we are studying the chapters, okay? Because I found many of you still not clear what is a charge of quantization of charge. So we'll define that term. Then we shall not only define the term, we shall not only write the expression just like that we did in grade 11. We just define it. We just wrote it down, the expression. But here we'll be deriving that expression, okay? Through an experimental procedure, and that experimental procedure is given by Millikan's-Waldrop experiment. So Millikan's conducted, okay, an experiment known as Millikan's-Waldrop experiment, and through that experiment, we'll be finding out how charge is quantized. We'll be finding out the expression Q equals to plus minus NE. Okay, so that was the first chapter. Now the second chapter is here. As you can see here, what happens when this one, okay, this packet of energy is known as photon. Yes, we shall study later on what we mean photon, on all these terms we shall study. But if you have to have an overview, what we'll be discussing in this chapter number 2 is this discrete packet of energy will come and strike this electron, and sometimes it may eject the electron, okay, or emit the electron from this atom. Sometimes the energy of this photon may not be or is not capable enough of emitting this electron. So we're finding out when this discrete packet of light, okay, in grade 11 we studied that light is a wave, okay, and it is in continuous form. And then here we'll be studying the particle nature of light. Okay, and that is a very nice experiment that is known as photoelectric effect, and it was discovered, or that photoelectric effect was discovered by a great scientist. His name, as you know, is Albert Einstein. Okay, and then he got the prize, Nobel Prize on it. So we're studying that experiment where Einstein got the Nobel Prize in chapter 2. So here it's very interesting. Okay, modern physics, and then so in grade 11, we study about the continuous or the wave nature of light, the continuous nature of light. In grade 12, in this chapter known as photon, we'll be studying about the particular nature of light, okay? And that particle of nature of light will develop that idea that light is a particle from a very famous experiment from which Einstein got the Nobel Prize, and that's obviously photoelectric effect. So see, it's very interesting, okay? Then after that, we'll find out the Planck's constant, okay? The value of H, what will be the value of H, okay? And then it's given as 6.62 into 10 raised to power minus 34 joules second. Then how can we determine that Planck's constant? So this is also Millikan's experiment, and many of the students get confused here. When teacher asks, or when in the exam the question is asked about Millikan's experiment, they get confused here. Either they have to find out the Planck's constant, or they have to find out the quantization of charge, okay? So this determination of Planck's constant, the experiment of Millikan is different to that of determination of charge quantization, Millikan-Waldrop experiment. Here also Millikan plays a vital role, and here also Millikan experiment plays a vital role, okay? So here we'll be discussing about the Einstein experiment, that is known as photoelectric effect, and Millikan's experiment in order to determine Planck's constant. And we'll be having that concept that light is a packet of energy, and then it is particle in nature here, okay? Just different from what we have studied in grade 11 in optics. Then this is the second chapter of photon. Then we finally come on to the quantization of energy. And now here, what it does is that what happens when this electron falls from this higher state to the lower state? Yes. And then how does the electron from this lower state, so here if you happen to see here, how does the electron from this lower state moves to higher state, how does the electron from higher state comes down to lower state. So how we can quantize energy. So here is the very important topic. Here it has been given the name itself as quantization of energy. So what we have seen here in the first chapter is quantization of charge. Okay, we'll be studying about how the charge is quantized. So here, all these three chapters, how they are related. Okay, this first chapter is quantization of charge. The second chapter is quantization of light. Okay, light is quantized. Okay, it's a discrete packet known as photon. So it's quantized. So in the first chapter, we'll be studying about quantization of charge. In the second chapter, we'll be studying about quantization of light. And in the third chapter, we'll be studying about quantization of energy. Okay, so these are three different chapters that we'll be studying. And not only there are three chapters, there are 9 chapters. So these are similar chapters. And we try to cover this within the first term of our, within the first term, we'll be trying to cover, we have to cover, otherwise we may be late in our syllabus. So we'll be covering the first chapter electron, the second chapter photon, and the third chapter quantization of energy. And all these chapters are somehow related to electron, not somehow, highly related to electron, the properties of electron. Okay. Now after this one, I have got check your understanding. So what I'll be doing is that I'll be asking individually, and then you have to reply. Okay. So let me come here. So we is here. Let me see. Okay, Soya, please unmute yourself. Soya, say hello. Soya, Jago. Audio solve, sir. Okay, fine. Try to make it. Okay, Yankila, please unmute yourself. Okay, say hello. Yankila. What's happening, Yankila? Your audio is also not working properly, is it? Hey, interact. Otherwise, what's the use of studying? Huh? What? Your audio is not working, Yankila? You please, if your audio is working, you try to unmute yourself and then tell yes. Okay. Okay, Nitya. Nitya, sir, unmute yourself.
Sir.
Okay, thank you so much. Finally. Okay, Nitya, what do you think the answer of question number 1 is? So question number 1 is, we studied the wave nature of light in geometric optics in grade 11. We'll study the particle nature of light in grade 12 in the chapter named. So the question is, yes, we study about the wave nature of light in geometric optics. Okay, and I was a teacher there. Now we'll be studying the particular nature of light in grade 12. But in which chapter? Is the chapter named electron, photon, or quantization of energy? Nitya?
Photon maybe.
Maybe photon. Okay, yes, you are absolutely correct. Okay, we'll study the particular nature of light in grade 12 in the chapter named photon. Thank you so much. Now, let me see who is here. And then do not get disconnected from the class when I ask you, okay? Okay, come on, unmute yourself.
Yes, sir.
Okay, now I'll be asking you the second question. The second question is, study of spectral lines suggests us about the type of elements present in stars. We'll develop our fundamental ideas on spectral lines in the chapter named. So I did not
So maybe electron.
Okay. Okay, nice try. Okay, come on, you mute yourself, and Lisa, unmute yourself, and then just suggest if come on is right. Lisa?
Yes, sir.
So is do you think that
Quantization of energy.
quantization of energy. Okay. So here are two answers. Okay, one from common is electron, and from Lisa is quantization of energy. Now, Lisa, mute yourself, and then Serena. Serena, which do you think is the correct answer? Do you want to go towards common side, or do you want to go towards Lisa side?
Sir, I think Lisa is correct.
Yes. So let us discuss, okay, about this one. Yes. Thank you so much, Serena. Okay. Yeah, we study about the spectral lines in the chapter name as quantization of energy. Okay. So here, if we see here, so here what you are saying is this. Though I did not discuss it properly, so I want to discuss it now. So here these electrons, if they receive, I think you have studied in chemistry as well, if they receive energy, sufficient energy, then they move to higher orbits, right? So as they move to higher orbits, they can't stay here permanently. Yes, they have to come back and then maintain the stability position. I think you have this, you know about this one, right? Whenever someone provides you a gift, suppose father gave you or bring you a gift on your birthday, and you become very excited, but you won't stay at that excited position ever, do you? Yes, you'll be in stable position. After a few days, you again will come back onto the same position which you were before father gave you the gift. So will be every object in this nature will be staying in the excited state only for certain moment of time. Finally, they want to come onto the stable position. Okay, and while they come onto the stable position, they will be releasing the energy. So for an example, you are playing futsal and you are very excited, and then later on, what happens while playing futsal? You release your energy, and finally you come to the rest position, right? So this is simple an analogy. So whenever you are excited, then after being excited, you come on to the rest position or normal position, then you'll find that something or some amount of energy is being released from your body as well, right? So similarly, it happens in an atom as well. Okay, the atom from the lower state will come onto the excited state, yes, by getting some energy, just like you come onto the excited state by getting gift. Then you won't be staying on that position. Similarly, the electron on the higher orbit also doesn't stay on the same position. It comes down, falls, and then maintains its natural state. Yes, on doing so, it releases energy. Okay, and this study or the release of all these energies will be studied in this concept or the terms known as spectral lines. So all these spectral lines are formed because of that excitation. Okay, excitation of the electron from lower orbit to higher orbit and back to the lower state. Whenever it comes back to the when it gets from lower state to a higher state into the absorb energy, so it's known as the absorption spectrum. Then when it maintains it higher state and it finally comes to the lower state, it releases energy, and that is known as the emission spectrum. Okay, so there will be two spectrum, and all these spectrum will help us to understand better about these spectral lines. And these spectral lines are used to find, okay, the scientists use these spectral lines to find out what are different elements present in the stars. We can't go to the sun, right? We can't go to the sun and find out what are different elements present there. So what do scientists do is that they will study all these spectral lines, and then they will try to find out what are different elements present in the star. So here, it's a very interesting chapter, and it's a very interesting course, okay, that you'll be doing in grade 12. So after going on to these three chapters, the three chapters were the first chapter electron, the second chapter photon, and the third chapter quantization of energy, and all the chapters relates to electron. Then we come on to the second category of chapter. Here are two chapters. Now, let me ask someone. Okay, I've asked Prithvi, I've asked Rasi, Sriyam, I think I missed Sriyam. Okay, Sriyam, unmute yourself. Sriyam?
Yes, sir.
Okay, thank you so much, Sriyam. Now, see here, what's the difference between this figure? Are you seeing? What's here? Tell me. Are you seeing this figure? Yes or no?
Yes, sir. Yes, sir.
Okay, what's the difference between this figure and this figure? Tell me the difference between these two figures.
So that is an electron.
Here is an electron, but here is no any electron. Yes or no?
Yes, sir.
Yeah, so this is devoid of electrons. So here is only what? Nucleus. Okay, so these two chapters deal with nucleus. These three chapters deal with the atom where the electron was also there. Now we just took away this electron, okay, and then we made this atom devoid of electron. That means we have got only this nucleus, right? Okay, so these are the two chapters that we'll be studying in modern physics is related to the nucleus. So the first chapter we'll be studying here, this region. So see here, as you have studied in chemistry in grade 11, you did study, right? A nucleus is small in comparison to the atomic mass. Okay, so see here, it just spans a very little area, okay, in comparison to the whole atom here. If you see here, so if there is, this is an atom, and in comparison to the size of an atom, the size of a nucleus is very small. Okay, and then here in these two chapters, in the first chapter here, you'll be studying about the nucleus, this region. Okay, this region you'll be studying, and what are different components here. Suppose in section C here are our 7 students, okay, including me. That means here are 16 students. Similarly here in this region, what are different particles we can find. So we'll be studying that one, and obviously I'll be studying in grade 11 what are different particles you can find out here. Okay, then we'll be studying that one. Then we'll be studying about what is the size of the nucleus, and then we'll be studying about the mass effect. Okay, so basically here what you'll be studying is what in my mass effect. You will study later on that if protons and electrons are measured, the mass of protons and electrons are measured separately, and if we bring those same number of protons and electrons, not electrons, protons and neutrons, and bind it. Okay, so just listen to me properly. We are measuring the mass of protons and neutrons separately in one scale. Okay, suppose there are 2 scales. In one of the scale, there is the mass of, there are protons and neutrons, and in another scale, there are the same number of protons and neutrons forming a nucleus. Now, if we measure the balance, or if we compare the weight of these two balances, one balance where there are protons and neutrons, and other balance where there is a nucleus that is made up of the same number of protons and neutrons. Okay, then what you find is there is difference in the mass. So why does this difference come, and what are different advantages of these differences, we'll be studying here. Okay, so not only we'll study about the nucleus, we'll also study about the mass effect, and from that mass effect comes the binding energy. We'll be discussing about the binding energy. Okay, and here only just like we won't be studying about nuclear energy here, we'll be studying it here. So here you'll be studying about in the chapter known as nuclear physics, we'll be studying about the nucleus. Okay, different constituent of nucleus, the diameter of nucleus. Okay, and then we'll be studying about the mass effect, just as I've said you, what's the difference between the protons and neutrons and the nucleus that is made of these protons and neutrons. What's the difference in the mass? We'll be understanding that one, and after understanding that one, we'll be finding out binding energy. What binding energy? We'll be discussing about all this one. So in this chapter, we'll be discussing that one. Then finally, here what we'll be discussing is that it's really it's a very useful concept that you will develop in this chapter, radioactivity. What you can do is that you can transmute the nucleus. Okay, so if you have the nuclei of, or the nucleus of one element, then you can change it into the nuclei of another element, or the nucleus of another element. How is it possible? Okay, all these one we'll be discussing here in radioactivity, and it's a very, very interesting and very useful topic here. So studying this radioactivity, you'll be able to understand how a nuclei of one element, or how a nucleus of one element can be converted into a nucleus of other element. Okay, and there are different processes that we'll be discussing here. And then not only that one, in this chapter you'll be being an archaeologist, something like that one, right? So what happens, people find out how old certain object is. Similarly, scientists will find out how old the certain object is, but that object has to be of biological origin. Okay, how old that object is. So in order to know how old certain bone that we find while digging the earth is. Scientists have used this concept of carbon dating, and it comes in radioactivity. So it's really interesting. So whatever the chapters we have been discussing here, they are really interesting, and okay, and they will really develop very high skills in physics. So as I mentioned here, so this was the first nuclei, man-made nuclei, okay, and this is related to hydrogen isotope. This is the first man-made nuclei, and it was formed by reacting nitrogen and helium, okay. So in the nitrogen nuclei, when this alpha particle come and strikes, okay, then what happens is this hydrogen isotope is formed, and this is the first nuclei, man-made nuclei, okay. So reading this one, we shall find out how we can convert one nuclei or one nucleus to another nucleus, okay, or the nucleus of one element to another element. So these are two similar, and this deals with nuclear physics. These are two similar chapters. And now here again I have got a question for you, and let me see who are left over here. So Yankila and Soya's audio is not working. Susang Ajax, Simserin Ajax, Rasi Ajax, Nitya Ajax, Lija Ajax, Kaman Ajax, Swapnil Ajax, Hasina. Okay, Hasina, unmute yourself. Unmute yourself, and then do please try to tell the answer of this question, okay? So, oh no, again here. Sorry. Hasina, are you ready? Hasina? Hello? Are you listening to me, Hasina? Tell me yes or no. Okay. Okay, Hasina, this question. Answer this question. Scientists use the method of carbon dating to know how old the object of biological origins are. We study about the method in the chapter. Do we study about this carbon dating in the chapter nuclear physics or in radioactivity?
I think nuclear physics.
Is it? Is it? Okay, nice try. Thank you, Asina. You tried it. Let us see whether we are correct or incorrect, okay? And let us try to take the help of our friends. Prapti, Rasi, Sherina. So where are the rest of the friends I can? Okay. So Chetana, try to help Asina. Is she correct, or do you think we have to help her? Chetana.
So we have to help.
Okay, so what do you think is the correct option?
Radioactivity.
Radioactivity. Okay, you have come on to that one. Okay, thank you. Yes, help was required for our Hasina, and actually it's radioactivity, and a real nice help from Chetana. Okay, so we'll be studying about the carbon dating and the transmutation of nucleus, okay, in the chapter known as radioactivity. And in nuclear physics, we'll be studying about the nucleus, okay, and then we'll be studying about the binding energy in nuclear physics. I think you got it, right, Hasina? Okay, the second question is for Swapnil. You please unmute yourself, Swapnil.
Yes, sir.
Okay, so the second question goes for you, and it's just like this one. Okay, the sum of the mass of constituents of the nucleus, that is protons and neutrons. So nucleus is constituted of two elements. They are protons and neutrons. Measured separately, is always greater than the mass of the nucleus they constitute to form. Okay, so the mass of the constituent of protons and neutrons is always greater than the mass of the nucleus they constitute to form. This fact is known in the chapter. Is it known in the chapter nuclear physics or radioactivity?
Nuclear physics.
Okay, yes, thank you. It's known in the chapter nuclear physics. Okay, thank you so much. So after this one, so we went through five chapters up to now. Okay, the first chapter was electron, the second chapter was photon, the third chapter was quantization of energy, and the fourth chapter was nuclear physics. The fifth chapter was radioactivity. Then we also understood why we need to study. Okay, what are different skills that we can obtain from this 5 chapters. Now remaining are 3 chapters. Okay. So the first, so here, the 6th chapter is this one. So it's a standard model. Okay. Up to now we have studied that the atom is made up of electron, proton, and neutron. Now in this chapter we'll be studying that proton and neutron can be further subdivided. Okay, though electron cannot be further subdivided, we cannot break it. Yes, before we studied that atom was the building block. We studied that atom cannot be broken down. Then as different theories came around, and it was found that atom can be further broken down into electron, proton, and neutron. Proton and neutron lies in the nucleus, or they constitute the nucleus. They are nucleus and they constitute the nucleus, and electron revolves around that nucleus. We studied that one now. Okay, now we'll be studying that these constituent of the nucleus, that is neutron and proton, can be further subdivided. Okay, and they are constitute of quarks that we shall discuss later on. Though the nucleus, neutron and proton, can be further subdivided, electron cannot be divided. Okay, that we'll be discussing here in particle physics and cosmology. So we'll be discussing about the constituents of protons and neutrons. Okay, and then interesting thing is that we'll be discovering that the universe is expanding. Universe is not static. Universe is expanding, and it's given by Hubble's law. So that one will be discovered here in this chapter known as particle physics and cosmology. And then the 7th chapter is semiconductor physics. It's a very, very good physics. I really love it. Okay. Here in particle physics and cosmology, I study about, I did my research in the study of the star formation. So my research deals with this chapter as well, particle physics and cosmology. And then the second research was on electronics. Okay, and then I really love that. I really love this field because we are able to communicate now. Okay, we have got mobile, we have got desktop, we have got laptop. Okay, all these are possible only because of this field known as semiconductor physics. And it was really an enjoyable moment for me while I was doing the semiconductor physics. Okay, the research on this one. And I did the research on transistor. So once I think you have studied in the history of computer, the computer was of the size of the building. Now you can find it out in your mobile, right? All these computing devices and all the features of computer are in your pocket now. It can be hidden inside your pocket. So how is it possible? Because of the devices like transistors. Okay, so we'll be discussing about that in semiconductor physics. So really interesting topic. Another is, I think you can see it here. Okay, do not think that this is there in Bhaktapur, like brick factory. Okay, so the factory that makes the brick, or they also have this sort of chimneys and etc. But it's not that one. Okay, it's the nuclear power plant. So we'll be studying how we can generate energy from the nucleus. Okay, there are different reactions known as fission reaction and fusion reaction. Though the power plant for fusion reaction has not been yet developed, but for the fission reaction it has been developed. So we shall be discussing about what are different ways or what are different reactions by which the energy can be extracted from nucleus. Okay, it's a really interesting topic. And then we'll be discussing about pollution. Okay, all these pollutions, what are different pollutions that occur in the atmosphere. So all this one we'll be discussing. So this is the overview of the syllabus. I think it is 10:30 and it's our time is over. I shall put this recorded video and then we'll give you the link as well. So thank you for attending here. Okay, so how many of us are left? Finally, we are 14 in numbers. There were 17 in the beginning, 3 or 4 left. I don't know why. I think I was asking you the questions, right? That's why they left. So thank you so much, students. So and in the next lecture we shall follow, or we shall continue from here. Okay, thank you so much. Thank you.